My name is James Sample, and I'm going to talk to you about the data storage and the data visualization aspects of SeaBee. So we've had quite a lot of talks today already that have described the different individual components of the SeaBee platform. I'm going to talk about how we try and bring them all together in one place and then connect them up so that we can build automated data pipelines that do standard, consistent processing of our most important workflows. And by bringing everything together in one place, we also have the opportunity to build data analysis tools targeted towards particular user groups, and we can share SeaBee data as well. And there's this idea called the FAIR principles, which is that publicly funded data should be made publicly available. And so we have an obligation to make our data findable, accessible, interoperable, and reusable. And so another major goal of the SeaBee platform is to enable us to meet these obligations to make SeaBee data fair. This is a high-level sketch of the main data flows on the SeaBee platform. Over on the left, we have the fieldwork, which you've seen in some of the earlier presentations. So we're flying drones, we're collecting images, we're collecting ground truth data. And then over on the right, you have the users who would like to access SeaBee data and use it for their own analysis. Everything in the middle within the dashed outline, that is what I'm calling the SeaBee platform. And there are lots of different workflows running on the SeaBee platform. The two main ones, we have the blue arrows, which we call the training pipeline. This is a set of workflows that runs occasionally. So when we need to update our models or when we generate more annotation, more training data, we can run this workflow, update our machine learning algorithms, and then deploy them on the platform. So that is really what Arnt Børre described in the previous presentation. In my presentation, I'm going to focus on the red arrows. So this is the production pipeline. These are the workflows that are running constantly, waiting for new data to be uploaded. And when we get new data, it gets picked up automatically, processed in a standard way, and then published so that it becomes available to people wanting to use the platform. So we start off in the field. These pictures are taken from the 2023 seabird survey, which Sindre talked about. The main purpose or the main goal for the SeaBee platform from the fieldwork perspective is to make it as easy as possible for drone pilots to get their data onto the platform. So there are some things that the pilots always have to do, some information that they have to provide, but as much as possible, we try and extract the data from the raw images. So we can pull the sensor name and things like that from the EXIF information in the raw images. We can also get the location, so we can build the mission name, so we can geocode the filter and the communer and the nearest place. We can restructure the data into a standard format and try and make it as easy as possible to get it uploaded. And on the image on the bottom right here, you can see the data being uploaded directly from a boat straight after the mission has been completed. And it's important that we make this as simple as possible because these surveys are quite intensive. NINA are flying 20, 30, sometimes even more missions per day, and they do that day after day after day. So it generates a lot of data, and we need a smooth way of getting it onto the platform. Once it's been uploaded, this is where it goes. So this is the Sigma 2 data center in Vestland. It's a former olivine mine. It's this huge network of underground tunnels. It's quite a cool location. I think it was an active mine until 2009, and then in 2017 it was converted to a data center. So all of our SeaBee data and all of our workflows are deployed within this data center. One of the nice things about this location is that it is one of the greenest data centers in Europe, and that's important for SeaBee because, of course, we're a project that aims to support sustainable management of the coastal zone, but we use a lot of AI, and the environmental footprint of AI is quite a big topic. So it's nice that we can deploy our workflows here. Some of the things that make this data center particularly green are, firstly, it's located right on the edge of a deep fjord, so they take cooling water from about 100 meters depth. That minimizes the amount of energy that they need to spend on cooling. They're also located very close to a hydropower plant, so they have a relatively green source of electricity with minimal transmission losses. And of course, the mine was already there. It's all underground, so the visual impact is low compared to building an entirely new data center. Once we have the data on the platform, the first step in the automated processing is usually stitching the raw images together. So it depends a little bit on what kind of data we're talking about. The hyperspectral data is a slightly different workflow. I'm not going to talk about that today. The most common kind of data that we have on the platform is RGB and multispectral data. And as you've seen in the previous presentations, the raw data essentially consists of individual images, the kind of thing that you would take with a normal digital camera. So we upload hundreds or sometimes thousands of individual images per mission, and then we use Open Drone Map, specifically something called Node ODM, to stitch those together. And the first major output that we get is an orthophoto, the thing you can see on the right here, and then we also get some secondary data products as well, like elevation models, the digital terrain model you can see in the middle. We try to use open source software as much as possible on the platform. Open Drone Map has been fantastic. It works really, really well. It's very robust, and it just sits in the background processing up to about 12 missions simultaneously. And if more data than that is uploaded, you can see in the table on the left, the missions just get queued up and then they're processed as quickly as possible. Once we have the orthophoto, the next step is that we want to classify the images in some way. And so when the pilots upload the data, there's this attribute that they can set. Classify can be either true or false. If it's set to true, as soon as we get the orthophoto, it gets handed over to the machine learning models, and we try and apply those models to, for example, count the seabirds. So in the image on the left, each of the red boxes represents a seabird that's been identified, and if you click on one of those boxes, you can get the attribute information that you see in the middle of the slide here, which tells you the species that the algorithm has identified, and also the confidence score, so how confident the algorithm is that it's got the answer right. And then on the right here, you can see an image that I think Sindre also had in his presentation. So this is an example of just how detailed the latest drone sensors are. So this is a 120 megapixel sensor from 60 meters elevation. And these images have improved a lot, even over the course of SeaBee. In the 5 years that we've been doing this, the quality of the imagery that we get has improved significantly. And of course, at the same time, the AI algorithms are becoming much more powerful. And as these two things develop in parallel, the potential for SeaBee keeps increasing, I think. And then here we're doing the same thing, but this time we're doing habitat classification. So it's exactly the same pipeline. The only difference is that if it's a habitat mission, we pass the orthophoto to a different set of machine learning models, and we can generate the kind of maps that Christina showed in her presentation, habitat maps for the shallow coastal zone. The final step in the pipeline is data publishing. So we have the orthophoto and we have the machine learning products, and now we want to make them available. And again, this is something that the pilots can control when they upload the data. There's this publish attribute. If they set that to true, then it will be automatically published as soon as the machine learning step has completed. We use GeoNode, which is an open source platform for publishing geospatial data, and that gives us a public web interface where you can search for SeaBee data, you can explore data sets, and you can also download the data for your own use as well. By default, everything on SeaBee is publicly available. It's all free to use. In order to download data, you need to register, which is free. And that gives you an account on the SeaBee platform. It's just so that we have some idea of who's downloading what data. And when you register, you also get an account that allows you to build custom maps on the SeaBee platform. You can save them on the platform and then share them later. I'll show you that in a moment. This is the main interface for the SeaBee GeoNode. You've seen several examples of this already. The main map interface shows the missions, Then you have a list of the missions over on the left. You've got some filter and search options. Top right is where you can register and then sign in. And if you click on the little blue information icons associated with each mission, you'll get some additional details. So you get a pop-up information here where you can see a thumbnail of the orthomosaic. And so now you can zoom in to the area where the mission was flown. You can overlay the orthophoto on the base map. If there's machine learning outputs, you can add those as well, and then you can explore the data in detail. If you're logged in, you can also download the raw raster data and the machine learning outputs, for example, for use in your own GIS analysis. And we also make sure that all of the layers published on the SeaBee GeoNode are exposed as web mapping services as well. So if you click on this WMS button, you'll get the parameters that you need either to add the SeaBee layer as a base map in your own GIS, or if you wish, you can develop your own third-party application and you can incorporate SeaBee data into that as well. There is another way to explore SeaBee data. So if you go to the datasets option that's highlighted in red here, then you can get an alternative view. So instead of the map view, this is just a list of all of the different datasets, all of the orthomosaics, all of the machine learning results. And you have some more advanced options for searching and filtering the data on the left. If you're logged in, you'll also have access to this maps option on the main toolbar there. And this is where registered users can build up their own maps. So you can build you get access to a simple GIS interface where you can add any SeaBee layers, and you can rename them, you can style them as you wish. You can have sliders like the example here that allows you to compare two data sets on top of each other. So in this example, I've taken a multispectral data set and an RGB data set from the same location and the machine learning outputs from those two missions and overlaid them. And so you build up your map like this, and then you can save it. And as soon as you save it, it's linked to your user account on the GeoNode, and you can share it with collaborators or make it publicly available to everyone. It's not quite as sophisticated as if you had your own desktop GIS. So if you wish, you can always download the data and do your own GIS analysis. But this is a very nice way of quickly and simply sharing basic data visualizations. The other option that we have for more advanced users is we have a Jupyter Hub running on Sigma. So this is aimed at people who are comfortable writing their own code to do data analysis. So we can give you access to the Jupyter Hub. You sign in through your web browser, so you don't have to install anything. And then you will have access to a Python and an R environment. So that's Jupyter Lab, RStudio, and VS Code. So you can log in, write your own code. And when you run that code, it's running in the Sigma data center at the same physical location where the data is hosted. So you get a very fast connection to the SeaBee data. You don't have to download gigabytes or even terabytes of data first. You can actually work directly on the platform. And in most cases, we'll be able to give you more computing resources, certainly than you have on your laptop. So it's quite a powerful way to interact with SeaBee data. And it also means that if you build your own workflows and you test them on the Jupyter Hub, on the Sigma platform, we can immediately deploy those as new components of the pipeline. It's easier for us to do that than if you build it within your own local environment, and then we have to translate that across to our environment on Sigma. Okay, that's pretty much everything that I wanted to say. I've included some links here. So the main GeoNode is at the top. There is a documentation website which describes everything that I've talked about in a lot more detail. We try and make all of the code that we write open source. So we have a GitHub page as well. If you're interested in the details, you can go there and see all of the code behind everything that I've shown you. And of course, you're welcome to contact me directly by email as well. Thank you.